In this video, we're going to review Android Fundamentals 3.2 unit tests. We're going to reference the Simple Calc project that we looked at in the last lesson, so be sure to watch that video for downloading that. Let's go ahead and open the project, and let's take a look at where we have our Java folder. And here, notice that we have a couple of what are called source sets, which is a set of source code. Here we have our main code, which we've looked at in the previous lesson. And then notice we have another one called test, and it's in parentheses. Go ahead and open that, and let's open the calculator test. When we look at this, we're looking at example source code for writing unit tests. If you take a look at the import statements and the way this is laid out, we're using JUnit, and we're using a few other dependencies to do assertions, equals, and is. So if you've never worked with unit tests before, unit tests allow you to write code that tests the logic and function of your app. In this example, we're looking at just the basic test cases. There is another type of unit test that can be run in Android Studio that would be called Android test. We're going to look at that in another video, but the difference there is the Android test suite runs on the device or on the emulator. So in this example, we're talking about unit tests that only rely on the Java source code, and there's no Android specific functionality that we're testing against. We have a couple of annotations here. One is run with, which tells us we're running with JUnit. This small test just indicates that all the tests are unit tests that have no dependencies, and these will run pretty quick. Here we're setting up a reference to our calculator class, and we have a reference as before. We're setting up the environment, and so we call a setup method where we're creating and instantiating this calculator class. And then we have our actual test, which is add two numbers, which then runs a calculation. Notice that it says assert that, and you pass in the value of what you're asserting, and then you're saying this is equal to, and you're coming up with the value. So this should resolve to true if everything is run properly. So in order to run your unit tests, there's a couple of ways to do it, but basically you can create a new configuration. You can right-click on here and choose Run Calculator Test, and there's a couple of options. We're just going to do the Run Calculator Test. When that runs, it opens the calculator, and it runs our test view. And so notice it tells us which tests were run, how long it took, so only a few milliseconds, and then it says test pass 1 of 1 test. There we can see the results. If it failed, we would see a result here. Let's test when it fails by changing this value here. We're going to change our assertion. Let's just change that to 3, and go ahead and right click and run calculator test again. Notice how it fails, and it says assert error expected is 3, but it was expected was 2. And then you can take a look at that, and it'll take you right to your class test. Let's go ahead and change this back. And you can also run this when you have the test console open. You can go ahead and click run here to run it a second time. And we're back to working properly. Now let's go ahead and add another test case. So the question becomes, how do I test everything in my code, and do I need to test every possible scenario? And the reality is that it would be impossible to check everything. So it's best to test things that are more unusual that would happen, or something that people may do accidentally, kind of certain edge cases, and you have to make a decision about that. For example, what happens if you do the add function with negative numbers, or with floating points, or really, really large numbers? We want to test to understand how that's going to behave. Let's add another method And so within here, we're going to say, and we're going to do the at test, and we're going to say public void add two numbers negative. And from here, we're going to follow a similar pattern. We're going to say double, which is the return value, and we're going to say result add equals m calculator dot add, and then we're going to say negative 1 and then 2. So those are the two values we're adding, a negative 1 and a positive 2. And then we're going to make an assertion. We're going to say assert that, and so I just press tab to get that one. Result add is what the value, and then we're going to say is equal to 1D. So that represents the result that we expect when we run this test. Let's add another unit test, and we're going to say at test. We're going to say public void add two numbers floats, and here we're going to say double result add equals m calculator dot add, and we're going to say 1.111f to represent float, then 1.111d to represent the double. So with that, let's then write the assert that, and we're going to say result add and then is equal to, and it's going to be 2.222d for double. All right, let's go ahead and run these. Since we've already got the window open, we can just go ahead and click the run button. Okay, so let's see what happens. So notice that our assert, notice here expected, and then the actual result was this long float. And so we need to address that. Notice here we have a precision problem with using float. So that the problem is, what about whether is it because of our test or is it because of the calculation? So when we write it to accept either a double or a float, we only care about a certain amount of precision. And so there's some wiggle room to test so that we can say this is close enough and that counts. We're not too worried about being exact. So in order to change that, we can modify the assert that, and there's a value called close to. So instead of saying is equal to, we're going to say is close. Here, let me back this up. We're going to say is close to, and then 2.222, and then the 0.01. Now we need to add this to, we need to import this properly. So we need to import the close to. And from here, we have, notice the import, we have the close to import statement, and now it's saying within an error or range. Let's go ahead and run this. And notice all of our tests have passed. So at this point, you get the idea of how we can use unit tests to test our code. The lesson suggests to enter a number of additional calculations. Let's just do a couple more. Let's do at test, and let's do a subtraction. So we're going to say public void sub two numbers. And again, we're creating a double, which is the calculation, and we're going to say result sub equals, and then we reference the calculator class and we say subtract, and we're going to say 1D, 1D, and then we're going to assert that result sub is equal to 0. So that's the expected result here. Note that we're using the D to represent the double because we're coming up with a result of a double. And so we're casting these as a double. That's why we're saying 1D plus or subtract 1D based on the calculation. Let's do another calculation. Let's do one for multiplying. So we'll say at test public void multiply two numbers. And we're going to say double result mul, M-U-L, for multiply, m calculator dot multiply. We're going to say 32d times 2d. And then we're going to say assert that result mul is equal to 64. Oops, there we go. Okay, let's go ahead and run this. And notice we have 5 of 5 tests have passed, all within 4 milliseconds. So as you can see, it's very quick when you're dealing with small tests and talking about just calculations against our Java code itself. Okay, this was a fairly short lesson, but hopefully this gives you an idea of how to work with unit tests. Again, in the future videos, we're going to talk about Android tests, and we'll cover that in detail later. But thanks again for watching. Be sure to like and subscribe and share, and have a great rest of your day.